Hi, welcome back, fourth graders. Today we're going to be comparing decimals. So our I can statement for today is I can use area models and number lines to compare decimal numbers and record comparisons using greater than, less than, and equal to. And today you're going to need paper and pencil for today's lesson.
All right, this is fourth grade, module 6, lesson 10, and in this lesson, we're going to continue comparing decimals, but this time we're really going to focus on two models. We're going to focus on the area model, and we're going to focus on the number line. So let's get started.
So in this set of problems, we're being asked to use the area model in order to compare our values. And so the idea is we're going to start with this first one right here. And so we're going to look at that 0.19. And what does that mean? Well, 0.19, we need to remember that that is 1/10 plus 9/100. All right? And then the 0.3, what does that mean? Well, that means 3/10, and there's nothing else. So if we wanted to, we could call it 0/100 if we really wanted to. So we're going to use these pieces of information to shade in our area. So I'm going to zoom in a little bit here. And the idea is, first, we've got right here 0.19. So that means we're going to shade in 1/10 plus 9/100. So 1/10 is going to look like, boom, there's our 1/10. Now, how are we going to shade in the 9/100? Well, what we need to do is we need to cut this 10th right here into 10 pieces. So we're going to cut that up into 10 pieces. So I'm going to cut it in half, and then I'm going to cut each half into 5 pieces. And because we need to shade in 9/100, I'm going to zoom in, and we need to shade in, zoom in and shade in 9/100. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is our model for 0.19. Now we need to model our 0.3, which right here is 3/10 and no extra hundredths. And so let's do that. We're going to zoom in a little bit, and we are going to shade in 3/10. So that's 1, 2, and 3. So there is our shading in for 3/10, and that immediately makes it super easy to compare. We can see that this only has 1/10, while this has 3/10. Case closed. We're done. It doesn't matter that we have these extra 9/10 here, because these 3/10 beat this 1/10, and case closed. We are now done. So what symbol are we going to use? We're going to use the less than symbol, because the smaller end is on the small number and the bigger end is on the big number. That's another way to use your little mnemonic for figuring out how that does, which symbol to use, instead of just saying, well, the alligator eats the bigger one. We could say this smaller side goes with the smaller number, bigger side goes with the bigger number. Now we're being asked to use a number line to compare our decimals. So what we're going to do, let's do 18 and 18.19. So 18.19. So really, since we're comparing 18 and 18, really all we need to look at is the decimal portion, 0.19 and 0.3. And that 0.19, we need to remember that's 1/10 plus 9/100, whereas this is just 3/10. Well, that's exactly like the problem we just did, because it's the same, ends up being the same. But let's show what that looks like on this number line. So you'll notice our scale. Here's 18 and 1/10. Here's 18 and 2/10. This is saying 18 and 1/10 plus 9/100. So these little dashes are actually the 900ths. So 18.19 is going to go right here. 18. So that's 18 and 1/10, and then 18 and 1/10 plus 900ths is right here. So I'm going to write that down, 18.19. And now, where does 18.3 go? Well, we can see it. It's right here. 18.3 is right there. And since 18.3 is on the right compared to 18.19, that tells you that 18.3 is larger than 18.19. So our symbol in this case would be the less than symbol. Now here in our mind, we can use any technique we want, the area model, tape diagram, the number line, and what we're going to do is we just need to enter in the symbol, the less than, the greater than, or the equals symbol. So what we're going to do is we're going to imagine what this picture would look like, and we can see that in the ones place, we've got 2 and a 2. So right now they're kind of located in a very similar place. Now we're going to look at the tenths place, and here is where you're going to see the difference. We see 6/10 here, we see 5/10 there. Automatically that makes this number 2.68 larger than the 2.54. Oh, if we want to go right here, boy, case closed immediately. We're comparing the ones place with the ones place, and we see that 9 is larger than 7, we're done. We can immediately know that 9.28 is larger than 7.28. And then, let's do this one right here. So let's compare tens. It's 110 versus 110, so it's tied. And then let's look at the ones place, and we've got 3 ones versus 3 ones, so it's still tied. Now let's look at the tenths place, and we've got 1/10 versus 1/10. It's still tied. And then we see that this guy has no hundredths. What about this guy? Well, he has no hundredths either because they didn't even write it down. So what does that tell you about these two numbers? It tells you that they are equal. Another way we could think of that is we know that 13.1 is the same thing as 13 and 1/10. Now 13.10 is the same thing as 13 and 10/100ths, which if we divide both the numerator and the denominator by 10, then we get 13 and 1/10, which is the exact same answer right here. So that tells us they're equal. Another way we could think of that, let's think of that 13 and 1/10. 13.10. What does this mean? Well, this means, I'm going to ignore this portion right now. Let's just look at the decimal. That decimal says you have 1/10, and this means you have 0 hundredths. So 1/10, done. That's another way to show that it's equal to 13.1. So we got a lot of ways for our students to be thinking about it, not to mention they could have used the area model or the number line model. More of the same, only this time they're throwing in the unit form of these numbers. So 57/10 we learned is 5.7, so that means these two guys are equal. Oh, let's look at this one right here. So let's see. This is 8.39, 8 holes, 8 ones, 3/10 and 9/100ths. All right, but here we've got 8 holes, 8 ones, but this right here, 39/10. So I'm going to decompose this to 8, and this becomes 3 and 9/10, because 39/10 is equal to 3 holes and 9/10. So altogether, this is equal to 11 9/10. So that tells us that the number on the right is larger than the number on the left. Oh, last one. We could do this. 3/10 and 22/100. Well, 3/10. Well, let's take a look at 22/100 first. So if we look at 22/100 and we're thinking about a place value chart, so you got your hundredths, you've got your tenths, you've got your decimal, and you've got your ones. Now, if you had 22/100, that means you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2. So there is our 22/100. But we have to remember that we can take these 10/100 and they equal 1/10. And then we can say that these 10/100 equal 1/10. So these get exchanged. These got exchanged. So what do we end up with? We end up with 2/10 and 2/100 left over. 2/10, 2/100. And so really, this is 0.22, and this is 0.3. And we can see that 3/10 is larger than 2/10. Done. That means the symbol is the greater than symbol. And that wraps up 4th grade Module 6, Lesson 10. We're using the area model and the number line to compare decimals.
Hey, welcome back. Now we're going to try 3 problems. So the first problem, shade the area models below, decomposing tenths as needed to represent the pairs of decimal numbers. Fill in the blank with less than, greater than, or equal to compare the decimal numbers. All right, so go ahead and give this one a try. Pause the video, and when you are finished, go ahead and resume so we can do number 2. All right, problem 2. Brian says that 6/10 is less than 60/100 because it has fewer digits. Jesse says 6/10 is greater than 60/100. Who is right? Why? Use the area models below to help explain your answer. All right, so go ahead, pause the video, solve, and then come right back for the third problem. All right, our third problem. Locate and label the points for each of the decimal numbers on the number line. Fill in the blank with less than, greater than, or equal to compare the numbers. All right, so go ahead and hit pause, and then we will go over your work. All right, how did you do? So number 1, we were supposed to shade the models and then compare the numbers. So the first one was 2300. So there should be 2 tenths, and then this one we had to break up into 10 smaller pieces and then color 3 of them. And that is less than 4/10. So we can see even though there's more digits, it's a smaller number because we have more shaded in for 4/10. All right, letter B, we have 6/10 shaded in over here. And on the other model, we have 3/10, and then that 4/10 we divide up into 10 pieces and then colored in 8 of them. All right, our next problem. Ryan says that 6/10 is less than 60/100. So who was right? So if we color it in, we see that 6/10 is 6 pieces colored. Over here, 60/100 is still 6 pieces colored. And even if we took that next one and broke them up into 10 pieces, we are coloring in 0 pieces. So 6 and 6, neither are right. 6/10 and 60/100 are equal. They both have 6/10 and 0/100. A little tricky there. All right, and then our last one, we were comparing this number on our number line. So we have 12 and 687 thousandths. So we have 12 and 6/10, 12 and 7/10. So somewhere between here we had to count. So we counted them and we said this is 12 and 61/100, and then 62, 63, 64, 65, 66, 67. Then we found 12 and 68/100. And then in that space we made very teeny tiny little lines to break it up into tens. And then we found the 7th line and labeled it 12 and 687 thousandths. And then down here, already labeled for us, was 12 and 8/10. So that one was a little bit easier. We can see that this number is larger because it's farther down on the number line. All right, well, I hope we learned something new today. Thanks for joining, and hopefully you'll be back tomorrow. All right, have a great day.